Welcome to another episode of Terry's Notes, and today we are going to be looking at the extraction of metals. When a metal is extracted from its ore, the process is a reduction process. For example, extracting aluminium from the ore aluminium oxide or bauxite. If we want to extract aluminium from this ore, the reaction that is taking place is Al3 plus 3 electrons produces aluminium. Because remember, if we have a bauxite is Al2O3 and the aluminium has a 3 plus charge, and the oxygen has a 2 minus charge. Alright. Now, if we look at the oxidation state of aluminium, it changes from plus 3 to 0. Alright, because in the aluminium ion, we see it has a 3 plus charge, and in the aluminium solid, the oxidation number is 0. So therefore we have a decrease in oxidation number, and this is called a reduction reaction. So therefore the aluminium ions are being reduced. Now, metals can be extracted by electrolysis of the molten ore. It can be extracted by heating the ore with a reducing agent, for example carbon or carbon monoxide, or it can be extracted by heating the ore at high temperatures. Now, what determines the choice of extraction method? The choice of extraction method of a metal is determined by its position in the reactivity series. Now you need to find a way to remember the reactivity series. At the top we have the most reactive element, which is potassium, and at the bottom we have gold. So reactivity decreases down the series, or we can say that reactivity increases up the series. So at the top, potassium is the most reactive, and at the bottom, gold is the least reactive. And we usually put in hydrogen as a reference within the reactivity series. Now, at the top, we have the most reactive metals. This means that the ores or the compounds formed have very high melting points, and therefore requires a strong method of reduction. So at the top of the reactivity series, we have to use electrolysis in order to extract the metal. At the bottom, the least reactive, these elements can exist as free elements, meaning that you can just be mining and you can extract gold, or it can also be extracted from the ore by heating strongly. And anywhere in the middle of the reactivity series, we have to heat the ore with a reducing agent, for example carbon or carbon monoxide. Alright, so just remember that the position in the reactivity series is what determines the method of extraction. So let's go back to what we were saying. What determines the choice of extraction? The most reactive metals in the activity series form very stable ores, and therefore requires a strong method of reduction. Therefore, electrolysis is the choice of extraction. The least reactive metals in the activity series can exist as free elements, for example gold. And metals that lie between the most reactive and the least reactive form relatively stable ores. However, they can be extracted by heating with carbon or carbon monoxide. Okay, so Let us first look at the extraction of aluminium, and this is one that you are required to know. So you need to know the ore that we are using. Okay, the first thing. So the ore is aluminium oxide. You need to know the formula. It's Al2O3 and is also referred to as bauxite. So we can get bauxite from Jamaica and also from Guyana. And the method, now remember, aluminium is at the top, or it's very reactive, and the aluminium oxide is very stable. So therefore the method of extraction is electrolysis. You need to be familiar with the steps in the electrolysis process. So the first step is to purify the ore. So you're going to have the aluminium oxide. You just need to purify it to get pure aluminium oxide. Second step, the purified ore is dissolved in molten cryolite, and the formula for that is Na3AlF6. So it's dissolved in molten cryolite at 950 degrees Celsius. Now why do we do that? The melting point of aluminium oxide is very high, 2050 degrees Celsius. Right? Why is it very high? Because aluminium oxide is an ionic compound, and you have Al3 plus ions and O2 minus ions. So the bond or the electrostatic force that exists between the oppositely charged ions are very strong, and that is why it has a very high melting point. So we said we take the aluminium oxide and we dissolve it in molten cryolite at 950 degrees Celsius. Now, a large amount of energy would be required to melt the aluminium oxide on its own. Mixing the ore in molten cryolite allows the electrolysis to take place at a much lower temperature. You need to know this because sometimes you are asked, why is aluminium oxide dissolved in molten cryolite? The next step, electrolysis is carried out using graphite electrodes. So this diagram shows how the process takes place. So we have a large steel tank, and we have the molten cryolite and the molten aluminium oxide as the ore. We have the graphite anodes, that is this and this and this, and the steel tank is also lined with graphite. So right, and this lining is a cathode, and these carbon or these graphite rods are the anodes. Now you need to know the two reactions taking place. So at the cathode, remember the cathode is negatively charged, so therefore the Al3 plus ions are going to move towards the cathode. So the Al3 plus is going to move towards the cathode, and the reaction taking place would be Al3 plus 3 electrons produces aluminium. At the anode now, we have, remember, we have O2 minus. These are going to move towards the anode, and the reaction taking place is 2 O2 minus 2 electrons produces oxygen gas. Now what is happening is that you notice we have bubbles being produced at the anode. Now the oxygen produced at the anode reacts with the graphite. So remember, graphite is carbon plus O2 produces CO2. So what happens over time is that the anodes have to be replaced because they are being used up, or the mass of the anodes are decreasing. Now the other extraction we need to be familiar with is the extraction of iron. In this case, the ore is iron 3 oxide, and the formula is Fe2O3, and another name for it is hematite. Now if you recall where iron is in the activity series, it is somewhere in the middle, So the method of extraction is the reduction of the ore using carbon monoxide in a blast furnace. Okay. Now, the steps in the extraction of iron. First step, a mixture containing iron trioxide, calcium carbonate, which is known as limestone, and coke, which is carbon, is added at the top of the blast furnace. So basically, you have the blast furnace looking like this. We have the ore, iron trioxide, calcium carbonate, and coke being added at the top of the furnace. We have heat here, and we say it's a blast furnace because a blast of hot air is blown in at the bottom of the furnace. Alright. Now what you need to be familiar with is the reactions taking place. So the first thing, the coke, which we said was carbon, reacts with oxygen to produce carbon dioxide. So C plus O2 produces CO2, and this reaction is exothermic. The second step, or the second reaction taking place, is that the carbon dioxide reacts with more carbon to produce carbon monoxide. This is an important equation here, but this reaction is endothermic. Now, the next reaction taking place is Fe2O3 plus 3CO produces 2Fe plus 3CO2. So you have the iron trioxide reacting with the carbon monoxide to produce iron and carbon dioxide. So this equation shows how we produce the iron. Make sure you familiarize yourself with this. So the first thing, the carbon reacts with oxygen to produce carbon dioxide. Then the carbon dioxide reacts with more carbon to produce carbon monoxide. And it is the carbon monoxide that reacts with the iron trioxide to produce the iron. Okay, so carbon monoxide is the reducing agent, not the carbon dioxide. And the molten iron flows out at the bottom of the furnace. Now, how do we treat with the impurities? Now, a major impurity in the ore is silica, or SiO2. And the high temperatures inside the furnace causes the limestone to decompose to form calcium oxide. Okay, so remember we added calcium carbonate at the top, which is limestone. So when we heat calcium carbonate, we produce calcium oxide and carbon dioxide. Now, the calcium oxide reacts with the silica to form calcium silicate, which is slag. So CaO plus SiO2 produces CaSiO3. And this layer floats on the molten iron and is tapped off. So this is how we treat with the impurities. Okay. SiO2 is acidic, and calcium oxide is a base. Alright. So, just to summarize, the position in the activity series is what determines the method of extraction. At the top of the reactivity series, we have the most reactive elements, and they form very stable ores. And therefore, we have to use a strong method of extraction, and therefore we use electrolysis for those elements. At the bottom of the activity series, these are the least reactive elements, and they usually exist in their free state. For example, gold. If they do exist as a compound, you just have to heat it strongly and you'll extract the metal. And metals in the middle of the reactivity series can be reduced using carbon or carbon monoxide. And the two extraction methods that you need to be familiar with is the extraction of aluminium and the extraction of iron. The extraction of aluminium is done by electrolysis, and the extraction of iron is done using carbon monoxide as a reducing agent.